This is John Black, Super Chemist. Just doing an easy video. People know I'm not dead. It's about cooling baths. There's two good sources that you can find out about different types of cooling baths, and they're both on Wikipedia. The first one is right here, cooling baths. Go to Wikipedia and plug in cooling baths, or plug in list of cooling baths, and you'll get a list. Anywhere from minus 269 degrees Celsius, up to like 15 degrees Celsius. And a lot of people know cooling baths, like right here. You see how you got the ice water and you got the flask in there. You're keeping it cool. Let's say you're mixing two things together and it's exothermic. You got the ice bath to cool, keep the temp down. Or if you're just doing something that has a low boiling point, you want to keep it, or a low boiling point, like around room temperature or something. You want to put an ice bath on it. See there? And most people know that part, but there's other types of ice baths, other than just ice water. And I used to know about when I first, read about dry ice and using it. I really at first didn't understand what they meant. What do I do with the dry ice? Because dry ice is a certain temperature. I think it's like minus 109 Celsius, or I'm not sure. But how do you get the different temperatures? What if I need to be at minus 10? Or what if I need to be at minus 77? How do I get it to be exactly, a smooth temperature, like throughout the whole reaction? Now, if you go to Wikipedia, like I said, they give you a lot more examples for the cooling bath. I'm just going to go over a couple here. Helium, if you can get liquid helium, you get down to minus 269 Celsius. They have stuff with nitrogen in it, but if you just use liquid nitrogen, you can get it down to minus 196 degrees Celsius. And if you mix it with other stuff, you can get other temperatures that are higher than that. Carbon dioxide, right here, that's dry ice. You can get anywhere from minus 82 degrees Celsius to 13 Celsius. Ice, anywhere from minus 40 to 0 Celsius. And this is just a little list here. There's a bigger list, like I said, on Wikipedia. But let's say you put dry ice inside benzene, right? You put it in benzene, you're going to get 5 degrees Celsius. Let's say you put it in isopropanol, you're going to get minus 77 degrees Celsius. The thing is these things won't freeze, you know what I mean? Trying to freeze isopropanol is, it's not going to freeze at minus 77. And they tell you different, like nitrogen. Let's say you put it in ethanol, you can keep the temperature at minus 116 Celsius. You know what I mean? Depends on what you put it in. You can put ice in acetone, and if you have a 1-to-1 ratio, you'll keep a nice minus 10 degrees Celsius temperature. Like I said, you can go look online and look on Wikipedia. They give you a lot better examples. Now, another thing you can use it for, so let's say you have a distillation set up like this and you have a vacuum pump, right? The hose comes to the pump and you pump it out. And that stuff, it just pumps it into the air unless you have a, what do you call it, fume hood or whatever, or you can lead it outside. But you could also see how the hose comes in, and you put the hose all the way down at the bottom of the flask. The flask is in some ice water, and so the gas is forced to, because it's coming this way, it's forced to come out and hit the flask that you have cooled down, a lot. And that way you won't get any water going to the pump. Now, I just have an example of ice water here. That's a bad example. You should really put some carbon dioxide, frozen dry ice, and, you know, maybe some isopropanol or acetone or something like that. Ethanol, something to really get the temperature down. And that way you won't be pumping it through your pump, ruining your pump. Now, if you have a good pump that just has the plastic insides, then it doesn't really matter. You don't need to worry about that. But it does cut down on pollution too, you know what I mean? Even if you have a fume hood, you know, you might not want to pump all that stuff into the air. This will help take some of it out, you know what I mean? So I just wanted to go over cooling baths and how you find the list, you know. How do you keep, because this is great for, it's not just, this doesn't tell you how to cool stuff down. It tells you how to cool it down to a specific temperature. You know what I mean? You might have a reaction that has to be between -70 and -80 degrees Celsius. You know what I mean? So you're going to use CO2, dry ice, and isopropanol. You know, you may need it to be exactly 5C, you know, or somewhere between 0 Celsius and 10 Celsius. So you're going to use dry ice and benzene. You know what I mean? You'll keep a constant temperature, you know what I mean, of 5 degrees Celsius. Anyways, that's about it. Like I said, it's a nice, easy video. I just wanted to let you know, you know, work is keeping me away from making videos. But you all have a great day, and always remember, science is great.